Welcome back. So let's look at the progress in aviation. Some of the progress. Now, we discussed already in the last lecture as to what was the distance that was covered by the Wright brothers in their first flight, which was only 120 feet. And what you see, what we can do today, then this is the Super Jumbo Airbus A380. We can fly for more than 14,000 kilometers with 600 people on board. So that's enormous progress. In terms of payload, you see here an Antonov 225. This is a Russian aircraft. It can carry a payload of 250 tons. The first flight had only the payload of a passenger. And with 250 tons, Antonov 225 can cover around 4,000 kilometers. Now, what is very interesting of this aircraft, apart from the fact that it has these 6 humongous engines, is the fact that when you look at the landing gear is really enormous. That always fascinates me. How could they build such a landing gear for this aircraft? Now, in terms of flight speed, there has also been a lot of progress. Of course, Concorde, we all know it. Concorde was the only supersonic passenger aircraft. It could fly at Mach 2.2 at an altitude of around 18 kilometers. That means that you could actually take off from Paris in the morning, let's say at around 7 o'clock, and you would reach New York before 7. So you could actually reach New York before the sun. So that was something which was very magical, of course. And it had very powerful engines, 4 engines from Rolls-Royce, Olympus. This has been the only successful supersonic passenger aircraft. Unfortunately, it's not being used today anymore, but it was operated by both British Airways as well as Air France. In terms of flight speed, another record was achieved by NASA in 2004 when the X-43A broke the barrier in terms of hypersonic speeds, and it could go to almost Mach 10. So that was, again, a remarkable achievement with scramjet engines. Now, what have we done in terms of civil aviation? So we have seen in terms of the range, in terms of payload. But one of the main progress for civil aviation has been the fuel burn. So on this graph, what you see is on the left axis, on the x-axis, on the left side, you see the change in the aircraft energy intensity, which means the amount of energy that the aircraft consumes per passenger. And on the right side, what you would see is the change in the thrust-specific fuel consumption of the engines. So all these aircraft, they use jet engines. We will look at jet engines in the subsequent lectures. And on the x-axis, what you see is the year. So as compared to the first jet-powered aircraft, which was the Comet, British aircraft, as compared to that, when you look at the current state-of-the-art new aircraft like A350, for example, then the fuel consumption reduction per passenger is almost 80% lower. So that has been an enormous progress. And that is also the reason why flying is so cheap, right? We can cross across continents for a few hundred euros. When you look at how was this fuel consumption reduction achieved, then there are many reasons to it. The main being the increase in the efficiency of the engines, and that's something that you see on the red dots of this graph. So the blue dots are actually represent aircraft, and the red dots, they represent the engines. So what you also see is that the specific fuel consumption, which is representing the amount of fuel which is consumed per unit thrust that the engine is producing. So the specific fuel consumption has reduced quite significantly. And of course, because the specific fuel consumption has reduced significantly, so the amount of fuel that needs to be carried on board has reduced, right? Or we can go for longer distances. Apart from the progress in terms of the propulsion system or the engine, Yeah, that has also been, of course, the progress with respect to materials, with respect to aerodynamics, with respect to control systems. Yeah, and so these are other technologies which have contributed to the reduction in fuel consumption of the aircraft. Okay, we will look at more elements about the propulsion system in the next lecture. Thank you.